What's up, geometry scholars? It's so close to the holiday break. You're excited, I'm excited, and we're also feeling pretty enthusiastic about these two warm up questions. Let's take a look at question number 16 from this year's Geometry Regions. It says, in the diagram below the quadrilateral ADBE, it says that DE is the perpendicular bisector of AB, and then it's saying to us which statement is always true. So I'm going to highlight the word always because that is what we're looking for, something definitive, something true. And here is what I know. I know a few things. I know that it says that DE is the bisector of AB. And so if DE is bisecting AB, that means that AC is congruent to CB. And that makes sense to me. So that means that like this red segment is congruent to this red segment. That's cool. And I also can't help but notice that it says that it's has a perpendicular relationship, and that's cool. So that means that obviously this is going to be a 90-degree angle, and then this is going to be a 90-degree angle. And our objective is to figure out again which of these statements are always true. I see that we have two angles congruent over here. We've got two pairs of sides that are congruent over here. And we just wrapped up our triangles unit. And I know that when I'm analyzing something that looks like this, one of the first questions I always ask myself is, are there any shared sides? So what I know is that CD is a shared side between these two triangles up here, right? And then I also know that we've got CE is a shared side. So what can we say? We can say that this triangle, ACD, is congruent to BCD, because why? Well, I see a side, an angle, a side. So we can prove that these two triangles are congruent because of SAS. Likewise, these two triangles are congruent because of SAS, and there's a whole number of other things that we can prove. And so let's think, which statement is always true? Let's take a look at option number one. Well, it says that angle ADC is congruent to BDC. So this is suggesting that this blue angle right here is congruent to this angle. And you know what, guys? I know that's absolutely true. And I know that you guys know that's true because corresponding parts of congruent triangles are congruent. And you know what? That is always true because we just proved that these two triangles are congruent. So option one is absolutely the answer. And if we take a look at the other options, so for example, if we take a look at option 3, it says that AD is congruent to BE. And you know what? We can't necessarily say that's true. And I know that because, well, what does this triangle share with this one? Well, they've got vertical angles, so they've got the A, right? They've got the S, right? This red segment is congruent to this red side over here. However, we can't say that CE definitively is congruent to CD. And so that holds true. That same idea holds true for option 4, and option 2, option 1 is the correct answer. Let's take a look at the next question in today's Do Now. It says in the diagram below, we've got lines L and M intersecting lines N and P to create a shaded quadrilateral. It says which congruent statement would be sufficient to prove this quadrilateral is a parallelogram. So you guys, here's what I know. We're looking for angle relationships. So we're going to be looking at all those posters on the front of the wall. And let's go through it one by one. And so what we're going to want to do is we're going to want to prove opposite sides of this shaded quadrilateral are parallel. Okay. And I can see that. I'm going to highlight this word right here. This is so crucial. Are parallel. So let's take a look at option number 1. So it says that angle 1 and 6. So I'm just going to do this like so. Angles 1 and 6, and then 9 and 14. 9 and 14. Well, first we need to recognize like what kind of angle relationship is this? Well, these are vertical angles, and this would not prove that line L and M are parallel, nor would it prove that N and P are parallel. So what we can do is we can rule out option 1 as a possibility. That doesn't make sense even a little bit. Let's take a look at option 2. So it says angle 5 and 10, and so let's mark this up to reflect that. So angle 5 and 10, okay. And then it says angle 6 and 9. So we've got 6 right here, and then we've got 9 right here. And so what do I know? Well, when I look at this, if these angles are congruent, I can't help but notice that they're in alternate sides of the transversal, and that would mean that this line, line L, is parallel to line M. But you know what? They're both of these angle relationships are proving that L is parallel to line M, and so sadly, that's nothing about this relationship will prove that N is parallel to B. So sadly, option 2 also not a possibility. We can rule that out. Let's take a look at option number 3. All right. 5 and 7, and then 10 and 15. Ooh, this looks interesting. So here we got 5, and then here we got 7. And so when we're taking a look at 5 and 7, what kind of angle relationship is this? Great, this is corresponding. Okay, and so what that's going to do is that's going to make line N parallel to line P, if that's true. Okay, and then we've got this other angle relationship. It says 10 and 15. Let's do that right now. So here's 10 in yellow. Here's 15. And here's what I know. What kind of angle relationship is 10 and 15? It's an alternate interior relationship. And so you guys, that's also going to prove that line N and P are parallel. But we've already got that. What we're looking for is to have both sides of this quadrilateral parallel to one another. So by process of elimination, what we can do is we can simply recognize that it's got to be option 4. And let's see why. So it says angle 6 and angle 9, and here we got 6 and 9. What kind of angle relationship is this? Oh, okay, this is alternate interior angles, and I can see that then that L is going to be parallel to M. That looks great. And then the other one, it says 9 and 11. Where is not? Here's 9. Here is 11. And you know what, guys? I recognize that 9 and 11 form a corresponding relationship, meaning that N has got to be parallel to P. So indeed, option 4 is the correct answer. Geometry scholars, let's take a look at some of these problems involving quadrilaterals, and we're going to kick things off with quadrilateral Fran, and it's asking us to do 3 unique things with this problem. It says that it wants us to prove that it's a parallelogram, it wants us to find the area of Fran, and it wants us to identify the perimeter. So very quickly, I know that you guys know that we can prove that this is a parallelogram by demonstrating that opposite sides are congruent. I know that you guys know that. I also know that we all know that if we can prove that opposite sides are parallel, that proves it's a parallelogram, as well as if we draw a diagonal from opposite corners and then identify that midpoint. If this coordinate is the same for both of these yellow diagonals, then that means the diagonals bisect one another, and that's another way we can prove that this is a parallelogram. So let's talk about that right now. So let's pretend, hypothetically, that we wanted to find the slopes. Let's pretend that we wanted to start off proving, for example, that the slope, which we'll write as M of NA, is what? It's going to be something over something. So I'm going to use my eyeballs. I can see that we're starting at 6, and then we're going all the way down here. So it's going to be down to 4. So it's going to be -4 over, and then this is, of course, 0, and it's going over 6. So it's going to be -4 over +6, which I know you guys know simplifies to -2 over 3. And then is that the same for segment FR for that particular side? It sure is. So let's write that like so. FR also has a slope of -2, 3. So if we do this and demonstrate and prove that NF is congruent to AR, that also works. What about the area? If we're trying to figure out the area, that can be a little tricky. And I'm not even going to lie to you. So when I was initially looking at this, I was thinking about that decomposition method that we were talking about a month ago. And so the very first thing I did was I wanted to box this quadrilateral, right? And then I was thinking, oh, okay, so here's what we need to do. We need to find this triangle, this rectangle, and then this blue triangle right here. And then I gave some further consideration to this. And you know what? We could simply identify the whole area and then this small triangle, this rectangle, this triangle, double it, and then subtract that from the entire area. But you know what, guys? That is OD. That's way too much. So a simple and easy way to go about doing this is simply applying the area of a triangle formula, which is base times height divided by 2. And so the base in this instance is going to be the green, right? This is the base. And then the height is going to be the red. All right. So I'm looking at this. The height, the height you can see is 4. I can see that the base is 6. You're going to figure out what the area is of this triangle and this triangle, and then you're going to double it. And so things are a little trickier down here when we're looking to find Jack. So what you're going to do is you're going to plot all the different points. And let's do that right now super quickly. I can't help but notice that J is 1, 3. So J is going to be right here. We've got A at 5, -1. And then C is 4, 2. And our objective is to identify all the different possible coordinates for K so that Jack is a parallelogram. It says, note that there are 3 possible answers. Find all 3. And then you're going to need to find the area of each parallelogram. And we talked about 2 strategies for doing that a moment ago. And then it says find the perimeter of each parallelogram. So how would we do that? Well, I'm going to let you figure that out. What I would say is if you need to figure out the perimeter of this, what we're going to do, and I suspect that many of us know this, we're going to apply that distance formula or the Pythagorean theorem. And so if we wanted to figure out NA, here's what I know. NA is the hypotenuse of this triangle, and I recognize that this length right here is going to be 4, and then this length, the horizontal length, is going to be 6, and I know that you guys know that it's going to be a squared, which in this case is 6 squared plus 2 squared equals c squared. So it's going to be 36 plus 16 equals c squared. And so what does that give us? 36 plus 10 is 46 plus another 2, plus another 6 is 52 equals c squared. We're then going to take the square root of both sides so that c equals radical 52. And you know what? We can simplify this further. I know that 52 divided by 4 is 13, so we can say radical 4 times radical 13, and then we can simply write, because the square root of 4 is 2, that c equals 2 radical 13. All right, so we figured out how to identify the length of one side. You're going to have to figure out the other sides to find the perimeter of Fran, but also to figure out the perimeter of the 3 possible parallelograms down here at the bottom. You're going to work hard. You're going to let me know if you have any questions finding the measure of these 4 sides. Let me know if you have any questions. Good luck.